Hello students, once again welcome to Bholanath Academy. In this video students we are going to see the preparation of ethers. So many ways we are going to prepare ether. In your syllabus only two raw material are there. With the help of that we are going to prepare the ethers. Okay students, so first is dehydration of alcohols. So alcohol will be your reactant students. From alcohol now we are going to form the product that is ether. If you will dehydrate the alcohols you will get ether. So D means removal. D stands for removal of water molecule from alcohol is called as dehydration of alcohol. We are going to remove small amount of water molecule from alcohols. When alcohol is, how we are going to remove students water? When alcohol is heated with dehydrating agent. So if students, if you want to remove water molecule from alcohol, you have to use dehydrating agent. Dehydrating agent means agent which remove water from alcohol, we call as dehydrating agent. Say for example students, here very concentrated sulfuric acid, phosphoric acid. If you use a dehydrating agent like sulfuric acid or phosphoric acid, S3PO4 or H2SO4, you will get two types of product will be two types. One may be ether, other may be alkenes. Can form depending upon the temperature. The temperature is very important students. So when alcohol is heated with dehydrating agent like concentrated sulfuric acid, phosphoric acid, two product, either you will get ether or you will get alkene. So two type of product you are getting students on dehydrating alcohols. So you will get ether or alkene. So when you will get the ether students, and when we are going to get alkene, that depends upon the temperature. Here temperature is very important. At low temperature students you will get ether. Say for example students, if you take the two molecules of alcohol, C2H5OH, you will use the dehydrating agent concentrated sulfuric acid, H2SO4, at 413 Kelvin. There is a removal of water molecules from alcohol. This is ethanol students. So students, this ethanol, two molecule of ethanol will eliminate one molecule of water, and here concentrated sulfuric acid is helping in removal of water molecule from ethanol, and you will find there is a formation of ether. So here we have used ethanol, so you will get, this is common name will be diethyl ether, or you can say, so this is ethane students. One hydrogen of ethane you are replacing with ethoxy, so it is also called as ethoxyethane, or you can say diethyl ether. Both are same students. So this way students, here the two molecules, say for example students, if two molecules are there students like this, C2H5OH, again students C2H5OH. Now what happens students, in presence of concentrated sulfuric acid, the one of the molecule hydroxyl group will combine with hydrogen of another ethyl alcohol, and they will eliminate water molecules, and you will find diethyl ether. Understanding students? So this way students, two molecules, this is first molecule and this is what, second molecules. So here students, at low temperature two molecule is required. Two molecule of ethanol on dehydrating, it will gives you one molecule of diethyl ether. This is at low temperature students. At high temperature, students, what happens? Here students, you have ethanol, one molecule of ethanol on using concentrated sulfuric acid at 443 Kelvin. This one molecule will eliminate water molecule, and you will find ethene, carbon-carbon double bond. That is formation of ethene. Understanding students? At high temperature you will get ethene. At low temperature students you will find ether. Understanding students? Now this is the ethanol students. Ethanol will give you ethene at high temperature. Now how it is students, it is giving. So this is ethanol students. I am writing a structure formula of ethanol. So two carbon students, C2, and this is total 5 hydrogens are there, and one will be hydroxyl group. So what happens students, only one molecule, this molecule, one molecule of ethanol will eliminate water molecules like this students. Hydroxyl of this carbon and hydrogen of this carbon combines, and they will eliminate water molecules, and you will find, and then what happens, this bond and there is a formation of carbon-carbon double bond. Understanding, students? So this way, students, you will get the ethene. So there is a formation of ethene at high temperature. In high temperature, only one molecule of ethanol will eliminate water molecules and it will form ethene. We are going to see the students preparation of ether, student, that is called as Williamson synthesis. What Williamson scientist has done, students, he has taken raw material as an alkyl halide. Okay, students. Now this alkyl halide, students, that we are showing with RX, this alkyl halide is treated with sodium alkoxide. Sodium alkoxide. This is sodium alkoxide or sodium phenoxide. You can use, students. Here you can use sodium phenoxide. This is phenoxide, students, to give dialkyl ether, or you can say alkyl aryl ether. If you use, students, sodium phenoxide, you will get alkyl aryl ether. If you are using sodium alkoxide, if you are using, you will get dialkyl ether. If you are using sodium phenoxide, at the time you will get alkyl aryl ether. This was discovered by Williamson scientists. So this is called as Williamson synthesis. Very important synthesis, students. So here, students, we are using in general, students, general reaction I am writing here, students. So here, students, alkyl halide raw material in both the first reactant will be your alkyl halide when combines with sodium alkoxide. Why sodium? This is alkyl and this is oxide, so this is sodium alkoxide. Here, students, sodium will be positive charge and this alkoxide will be negative charge. Now what happens, students? This sodium, now here also, students, this is negative charge and this will be positive charge. Now unlike charge attract each other, so what happens, students? Sodium will combines with sodium, it will combines with halide and form sodium halide. And what happens, students? Then this alkyl will combines with alkoxide of sodium alkoxide. This alkyl of alkyl halide will combines now alkoxide of the sodium alkoxide and it will form ether like this. So this way, students, formation of dialkyl ether. This is called as dialkyl ether. So this way, students, we have prepared dialkyl ether from alkoxide using sodium alkoxide. This is sodium alkoxide. We call as what? This is alkyl halide. Okay, students, same way, students, alkyl halide when combines with sodium phenoxide. So this is the aromatic ring attached to the oxygen, we call as sodium phenoxide. It is called as what? Sodium phenoxide. When sodium phenoxide react with alkyl halide, and this is sodium phenoxide. This is phenyl group attached to the oxygen, we call as phenoxides. So name of this salt will be sodium phenoxide. So here, students, we have used two type of salt, sodium alkoxide and sodium phenoxide. So in examination they may ask action of sodium alkoxide on alkyl halide, so you will find dialkyl ether. This dialkyl ether is very important, students. Now what happens, students, when it will combines, so this will combines with negative part of the alkyl halide and this is the positive charge. Now what happens, students? It will form sodium halide and there is a formation of alkyl aryl ether. There is a formation of alkyl and this is aryl, and because of oxygen is called as ether. R group we called as alkyl and this AR stands for aryl, and because both are attached to the oxygen, so we call as ether. So this way, students, we have got ether. We have prepared the ether. This is very important for the examination point of view. You can prepare any dialkyl or any alkyl aryl ether using Williamson synthesis. That is why this synthesis is very important, students. If you like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.